Hello, welcome to this lesson in algebra. The title of this lesson is called Simplifying Rational Expressions. And this is part one. There's several parts here that we're going to be doing. And in fact, the concept of a rational expression, we're actually going to be dealing with over the next, around 10 or so lessons in various forms. In this lesson, we're going to be talking about how to simplify these things that we'll talk about called rational expressions. Then we'll be talking about how to graph functions, which are rational functions, basically. And then we'll learn how to add and subtract these rational expressions and multiply and also divide rational expressions. So it's very, very important in algebra to understand this. The reason why it's important is because in real life, when you get to real equations down in the real world that we use to solve real problems, very often they end up being rational expressions. So we need to understand what that is first. So before I talk to you about what a rational expression is, I want you to think back to when you very first learned the concept of a fraction. We first learned what the concept of a fraction was, and then we taught you that you can simplify fractions. You can change the way the fraction looks, but it basically maintains the same exact meaning. So for instance, 3/6, 3 out of 6, 3 over 6 is the same as 1/2. They look different, but they represent exactly the same thing. So that's what we call simplifying fractions. So that's why we're starting with simplifying rational expressions. But later down the road, we learned how to add fractions, subtract them, multiply and divide them. Those were all separate skills. So we're retracing the exact same path with rational expressions. We're going to first learn what they are, how to simplify them, and then as we go down the road, we'll be adding and subtracting and multiplying and dividing them. So similar pattern. So, unfortunately, I don't think the title of this concept being a rational expression is a good one. It makes it sound very mysterious. A rational expression is very simple to understand. First, we've got to back the truck up a little bit. You may have heard the concept of a rational number in math. If you haven't, we're going to learn about it here. A rational number is a number, any number, that can be represented as a fraction. So any number that you can think of that can be represented as a fraction is what we call rational. You can sort of think of the idea of it being rational. You know, when we talk about something being rational, we think about it being well-behaved or something like that. Something that's not too abnormal, something well-behaved, well understood. That's rational. So those are things that can be written as fractions. Most numbers can be written as fractions. Then we have what we call the irrational numbers. And if we think about somebody irrational, it's somebody that's out of control or just kind of oddball, weird, kind of the exception to the rule. So we have the irrational numbers also in math. So we're going to have some parallels between that and rational expressions. So a rational number, if you recall from basic math, it's called rational, a number. So what a rational number is, it's a number that can be written as a fraction. Right? Any number that can be written as fractions. So let's take some very obvious examples. What about the number 2? Is the number 2 a rational number? Yes, it's a rational number because can I write it as a fraction? If a number can be written as a fraction, it's rational. So 2 can be written as the fraction 2 over 1. So any whole number, whether it's 10 or 15 or even negative numbers like negative 100, they can all be written over 1, so they're all rational, right? Of course, any fraction that you can think of, like 3/4 or 1/8 or 1/10 or 95/47 or anything like that, that's also a rational number. What about decimals? Sometimes people say, well, this guy's not a rational number because it's a decimal. But when you think about it, you can write the decimal 1.5, you can write it as 3/2. Right? Or you might think of a better example, 0.25, the decimal can be written as 1/4, right? So this decimal can be written as a fraction. This decimal can be written as a fraction. So all of these numbers, these decimals here can be written as fractions, so they're all rational. This fraction, of course, is a rational number because of the same thing, and this can be written as a rational number as well. So you might ask yourself, what's an irrational number? So irrational number. Those are kind of the special numbers, right? The ones that you learn about, but they're very special. So for instance, irrational numbers are numbers like pi, because pi is 3.14159 ... and it goes and it never repeats forever and ever and ever. You cannot write pi as a fraction. No matter what any teacher may have taught you, some people think that pi can be written as an exact fraction, but it can't. Pi is a never-ending decimal that doesn't repeat, and it can't be written as a fraction. Not exactly. Of course, you can approximate pi with a fraction, but you can't write it as an exact quantity as a fraction. Another example in math that we'll get to later is the number e, which is 2.7 ... with decimals that go on and never repeat either. They go off. They look random, but they're calculable by computers, but they never repeat, so they cannot be written as fractions. So these are very special numbers. They're irrational. So most of the numbers that you think of are numbers that are rational. They can be written as a fraction. So how are we tying this into algebra? And that's because the concept of a rational expression, which I already told you is very important because we're going to spend about 10 or 12 lessons on it. It can be written as a quotient of polynomials, right? So we've spent a lot of time talking about polynomials. We know how to factor polynomials. We know how to add polynomials. We know how to subtract polynomials. We know how to multiply polynomials. We know how to divide. Well, we'll learn how to divide polynomials here in a little bit. But the idea is we've learned a lot about polynomials. So when you have a fraction, which is what the word quotient means dividing by something. So if you have a polynomial divided by another polynomial, we call that a rational expression. The exact same way that we have rational numbers. They're written as fractions. Rational expressions are when you can represent the expression as the quotient or the division of two polynomials, any two polynomials. So just to give you a couple of quick examples, the expression 4x squared over y. This is a rational expression. Why? Because this is a polynomial on the top and this is a polynomial on the bottom. Of course, these are x's and y's. That's fine. That doesn't matter what the variables are. But if it can be written as a polynomial, which as you know is powers of x in descending order or powers in y in descending order, if you could write them as a quotient or the division of two polynomials, then it's what we call rational. Another example would be x squared plus 2x plus 7 all divided by x minus 3. This is a polynomial in the top, and this is a polynomial in the bottom. So this is a rational expression. So you could see it would be very easy for you to just invent many infinite number of rational expressions. All you need is a polynomial in the top of the fraction, another polynomial in the bottom. And just like we learned how to simplify regular fractions, like 2/10 or something, we learned that you can simplify 2/10 by canceling things in the top and the bottom of the fraction, dividing the top and the bottom, simplifying it into a lowest, kind of like a simpler form. We can simplify these rational expressions by doing the same thing or similar things. So it's better to demonstrate it by an example. Here's our first problem. What if we have the rational expression 5x squared minus 15x all divided by 10x squared? And I say, simplify this rational expression. So you have a lot of different tricks up your sleeve to do this, because as you all know, you've all learned how to simplify fractions in algebra, right? So for instance, we talked about the fraction 2/10 a second ago. We know that this is not lowest terms. Why? Because we can say, well, we can divide the top and bottom by anything we want in order to reduce these terms to something else. So what we look at is we say, well, we can divide the top by 2, but if we do that, we must also divide the bottom by 2. As long as we're doing the same thing to the top and bottom, then it doesn't change the meaning of the fraction. So 2 divided by 2 is 1, and 10 divided by 2 is 5. So even though 2/10 looks very different than 1/5, they actually represent the same thing. So here you might say, well, what can I divide top and bottom by to make this simpler? And it doesn't look like anything allows you to do that. But what you have to do when you simplify rational expressions, before you try to cancel anything or divide top and bottom by anything, is you try to factor. Factor everything in the top. Factor everything in the bottom. Once everything is in the factored form, then try to cancel. Because you can't, for instance, right now start canceling the x squares and the x squares. Why? Because this is joined together by a minus sign. So the only time that you can be canceling terms in the top and bottom is if you have terms multiplied together in the top and terms multiplied together in the bottom. Then you're allowed to cancel those things. So again, let's do it by an example. What can we factor in the top? We have a 5 and we have a 15. So the common factor there, we can pull out a 5. X squared and x, we can pull out a common x to both. So then we open the parentheses. to get this term, 5x would have to be multiplied by x. The minus sign comes along for the ride. 5 times 3 is 15, so it's going to be x minus 3 here, right? And you can just double check yourself. This times this gives you 5x squared. This times negative 3 gives you negative 15x. On the bottom, of course, there's nothing to factor because there's no extra terms here, so all you have is 10x squared. Now, because you have in the top of the fraction a term multiplied by a term, then you're allowed to cancel the x's here and also reduce the numbers. So let me rewrite it again so that I don't mark up what I already have, x minus 3 here, and then we have 10x squared. So just like we simplified the fraction over there, you know, here we said 2 divided by 2 is 1, 10 divided by 2 is 5. We can do the same kind of thing. So I'll divide top and bottom by 5. 5 divided by 5 is 1, 10 divided by 5 is 2. So I've gotten rid of the numbers here. And you can think of canceling the x's as fractions, or as dividing the top by x and the bottom by x, but the way we've been doing it in the past is we say we have 1x on the top and 2 on the bottom, so we can divide out one of them, which will cancel with this and leave us 1 left behind. But this is the exact same process. You could say the top divided by x gives me 1, the bottom divided by x, the x squared divided by x, is just going to give me x to the first. So if you want to think about it as canceling top and bottom, or if you want to think about it in terms of fractions, dividing the top by x and the bottom by x, just like we do when we simplify fractions, either way it's totally fine. So we cancel the terms, and what we're left with is we have a 1, there's no x's left over, so in the numerator all we have is x minus 3. In the denominator we have a 2 and an x to the first power, so it's just 2x. This is the final answer. So we have x minus 3 over 2x. So when someone says, simplify this rational expression, in general, what you're going to do every time is you're going to try to factor all of the expressions and look for anything common in the top and the bottom, or anything, if the numbers are present in the top and bottom, you simplify those, just like you simplify fractions, and then you try to cancel any other terms that you have, x's, y's, or any other common terms to top and bottom. What you get at the end of the day is a new expression, this one. But this expression is absolutely equivalent to the first one. They look different, but they represent the same thing, just like 2/5 looks very different than 2/10 looks different than 1/5, but they also represent the same thing. All right, so then, next problem. Now that we have the basics out of the way, x squared minus x minus 2, and on the bottom, x squared plus x. So now you can follow the recipe. Don't fall into the trap of trying to cancel things here. You can't cancel this x squared with this because you're linking it with all of these pluses. The only time you can cancel top and bottom is if you have products of things on the top. This is multiplied by this, and then this is all that we had. So then we can cancel things that are common once you have the terms multiplied together. But the rules of algebra prevent you from just striking through this because this was added to other things. So if you're going to do it, you have to factor first. All right, so on the top, we just factor. How do we factor binomials or trinomials like this? We open up parentheses like this. So remember, we learned about factoring before. So if you're not familiar with factoring, you're going to have to go back and refresh your memory on it because we're going to be factoring everything here. So the way we do it is we say, well, the first term has to be x times x gives me x squared. The last term can only be 1 times 2. And I'm trying to get a minus 2 here. So the only way it actually works is if I have a plus and a minus. And you double check yourself here. X times x gives me x squared. 1 times negative 2 gives me the negative 2. The inside terms give me x. The outside terms give me negative 2x. And when I add those, I get negative x, which gives me this one. So this is the correct factored form. For this one, I have a common term, x, I can pull out. So on the inside, x times x will give me x squared. And x times 1 will give me x. Double check yourself. X times x is x squared. X times 1 is x. So this is the factored form. So let me rewrite it again. We'll have x plus 1, x minus 2. And on the bottom, we'll have x plus 1. And then we say, do we have anything common? Well, you know, in here, we were canceling x with one of these x's with one of the x's that was part of the x squared. And here we were canceling numbers. But now you can sort of see that you can do that with x's, but you can also do it with entire terms. This entire term can be canceled with this. Now again, we say in algebra all the time, it cancels. It doesn't mean it disappears, poof, it goes away. What it means is, just like fractions, I can divide anything I want, top and bottom. Divide by 2 gives me 1, divide by 2 gives me 5. So really, when you're canceling, what you're saying is I divide the top and bottom by anything I want. Let me divide the top by x plus 1. That gives me 1. Let me divide, I'll put a little 1 here if I want. I'll divide the bottom by also x plus 1, the same factor, which also gives me 1. So when they cancel, they don't just poof disappear, they divide away, just giving you 1. So it kind of looks like it disappears. So these 1s, we don't always write them. We just strike through like this. And what you have at the end of the day left over is x minus 2 over x. And for the final answer, I could put parentheses around this if I want to, but I don't need to, because when it's over a fraction bar, you know that this is linked together as a term. So I don't need to keep these parentheses here, but I could. You could write them if you like. All right, so that's the answer to that question. Let me see how many more I have and see how much room I need. I think I'm going to be okay to go on the next board. All right, next problem. What if we have, we'll crank up the complexity a little bit. What if we have p minus q times q minus p to the negative 1 power? Now, remember, in the last few lessons, if you haven't watched them, we covered negative exponents. And we said we know exactly how to write negative exponents in terms of a positive exponent. You just take that term that has a negative exponent, you move it into the bottom of a fraction, make the exponent positive. We covered all of that in the last few sections, so if you haven't watched that, it might be a good idea because we're going to run across it a lot. So what we do to simplify this is we treat it like this, p minus q, and then that's multiplied by the fraction 1 over q minus p to the first power. You change it from a negative 1 to a positive 1 while we've moved it in the denominator. So what this really means is what you have is p minus q on the top and q minus p on the bottom, because the first power basically goes away. And since they're multiplied, you can kind of think of this as being divided by 1. So multiply the numerators to give me this, multiply the denominators, we have an implied 1 here, gives you this. So this is the answer. You could circle that. However, you know, when you see two terms that are very similar, but they're just kind of out of order, reversed, right? Then very often you can do a further simplification. So this is p minus q, this is q minus p. Don't they sound really similar? I mean, obviously you can't just strike through them because p minus q is different than q minus p, just like, you know, 2 minus 3 is different than 3 minus 2. But we know they're related because 3 minus 2 is 1 and 2 minus 3 is negative 1. So they're sort of the same. They both involve 1, but one's negative, one's positive. So what we can do is play around with this a little more to figure out a way to make it cancel. And once you do it a few times, it'll kind of seem like a trick at first, but it's not a trick. When you do it a few times, it will be something that you'll understand and just be able to apply yourself. On the top, let's leave p minus q intact. On the bottom, I'm going to get through it and then we'll talk about it. I want to factor something out of this. Now, you look at it and you say, I can't factor anything. I don't have a common q and I don't have a common p. However, I can always factor out a negative 1 from anything that I like. Anything that I like. And what it's going to do is it's going to flip the order of these terms around when I do that. Let's see if we understand how. If we factor out a negative 1, negative 1 times what will give me positive q? Well, I'll have to make that a negative q. And negative 1 times what will give me negative p? Well, I'll have to make that a positive p. I want you to stop here and soak this in and make sure you understand. Even though it doesn't look like you can factor anything out of the bottom, I'm going to pull out a negative 1. And when I do that, I'm claiming this is the same as that because negative 1 times negative q gives you positive q. That's right. Negative 1 times positive p gives me negative p. That's right. So if I multiply this stuff in, it's exactly the same as what I have. And so that's what you need to kind of remember because we'll use it a lot. When you factor out a negative 1, it basically changes the sign of both things on the inside. And now you'll understand why that's useful. In the next step, we'll have p minus q. We'll have negative 1. Notice if it's negative q plus p, I can just rewrite that as p minus q. Because I can just take and flip the order of the addition here and make it p minus q. That's exactly the same as negative q plus p. But now look, these terms are the same. If it helps you, I'll put a parentheses around that, and I'll rewrite it again. P minus q. On the bottom, I'll have a negative 1, and then I'll have a p minus q. And so now you can see exactly what's going to happen. You're going to have a strike through and a strike through. Now what's really happening is you're dividing top and bottom by p minus q, and you're leaving 1s everywhere. So what you really have at the end of the day is you're going to have, if you want to take it literally the way you have it here. You have a 1 on the top, you'll still have this negative 1 on the bottom. 1 divided by negative 1 gives you negative 1. That's the final answer. So even though it doesn't look like it, when you have this expression, it looks very, very weird, especially with the negative exponent. This expression, no matter what p and q actually are, whatever numbers they are, when you plug them in here and take the negative power and all that stuff, you're always going to get negative 1 as an answer, right? Always. So that's what that means. This is exactly equivalent. These are exactly equivalent. It doesn't look like it, but it is. And what it basically means is I can take any numbers here and put them in here for p and q, and I'll always get negative 1. In fact, just for giggles, let's do it real quick. Basically, this we said was equal to this right here. So it's p minus q, q minus p, right? So let's just pick something, right? Let's say p is equal to 5 and q is equal to 3. Just random numbers. I'm literally pulling them out of my head right now. So on the top, we would have 5 here, 5 minus 3. And on the bottom, q is 3, so it's 3 minus 5. 5 minus 3 is 2. 3 minus 5 is negative 2. What do you get? Negative 1. So no matter what values of p and q you put in here, you always get this. So when you simplify all this algebra and you get down to a number and people scratch their head and say, how can that be? There's no p's and q's anywhere. What it means is, no matter what value p and q are, you always get the same number. It's just one of those special relations that way. If I pick different values, you'll get the same exact thing. All right, let's move along. We have one more I'm going to do on this board, and then a couple that we'll do on the next board. All right, and so the next one is, what if I have s squared minus t squared, all divided by t minus s squared? Now you have to be careful. What does this mean? When I say s squared minus t squared, that means I multiply s times s, then I subtract t times t. So I do the squaring first, then I subtract. But on the bottom, it's different. This is the quantity t minus s times itself, t minus s again, right? So they're very different. Even though they look the same, they're kind of different, okay? They are different. So how do you simplify this? You first try to factor, and you say, well, I'll factor this. How do I do it? You're not sure. And you try to say, well, let me factor this. How do I do it? And you're not sure. So you're kind of stuck. But then you remember, anytime in algebra, when you have something squared minus something squared, it should go off, ding, 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 ding. We covered something called the difference of two squares. We've done that several lessons ago. And we use it to factor things and factor expressions that fall into the certain category. And it's used a lot. So if you haven't ever heard of something called the difference of two squares, go back to my lessons and watch the difference of two squares, because it's very, very, very helpful. So we've covered all of that before, and this is the difference of two squares because we have s squared minus t squared. We learned when we covered that can be written as s plus t times s minus t. This is the factored form of that. I don't have to think about it. I know that when I have two things squared with a subtraction, it can always be written as the plus and then the minus versions multiplied together. Check yourself. S times s gives me s squared. T times negative t gives me negative t squared. But in the middle, I'll have t times s, and then here I'll have negative t times s. And when I add them together, t times s plus negative t s, or subtract, you can think of it as plus and minus or just subtraction, they go to 0. So that's why there's no middle term there and it goes away. Now on the bottom, I have this squared, but let me blow it out here, and so it makes it a little easier. T minus s times t minus s. All right, so I get excited, and I say, well, I'm going to cancel something. This looks really similar. And then you say, well, wait a minute. T minus s is not the same as this, so I can't really cancel it. This t minus s, of course, I can't cancel it. And also, they don't match with this. So then you look at it, and you're like, well, I guess I'm done. I guess I can't do anything. But then you remember, wait a minute. He taught me that I can always flip the order of things by pulling out a negative 1. Where do I want to pull out a negative 1 from to make it work out? There's a bunch of different choices. But what I want to do is pull out a negative 1 from this term and try to flip the order and make it t minus s, so it'll cancel one of those. So let's just play around with it and see if we can get it to do that. So s plus t, that stays the same. And let me factor out a negative 1 from this. So you just write down negative 1 and you figure out what must go in here to multiply to give me this. So negative 1 times what gives me s. I'll have to have a negative s there. Negative 1 times what will give me negative t. I'll have to have a positive t there. You stop before you go on and try to make sure it works. Negative 1 times s gives me positive s. Negative 1 times t gives me negative t. So this is the same as this. So then on the bottom, I say, well, t minus s t minus s. So we're getting closer, but this doesn't quite look like this. Then you say, wait a minute here. The negative 1, let me go ahead and pull out and put it in front of the fraction. Then I'll have s plus t on the top. And then in here, instead of writing it like this, I'll flip the order, t minus s. And then in the bottom, all I have is t minus s 2 times. And now you see I can cancel with one of those. So let me write the fraction bar out front. S plus t, t minus s, t minus s, t minus s. And then I'll just cancel, which means I go strike through and strike through, which means I'm dividing top and bottom by t minus s, which means they divide away. And so you could technically circle as a final answer something like this. You could put negative s plus t on the top and then t minus s. Now, if it were me, I would probably just accept this as the right answer. All right, because you've done the hard part. You've factored everything, you've collected, you've canceled. The hard part is done. However, when you simplify when you simplify rational expressions, you generally don't want negative signs sitting out in front like this. You just don't. It's not that it's really wrong, it's just typically you just don't want to write down in your rational expressions negative signs out in front. So what we want to do is kind of get rid of that, but we can't just throw it in the trash can. It's there, it's part of the answer. But what we can do is we can either stick it on the numerator up here, or we can put it in the denominator, because when you have, I guess I'll go over to an aside here, when you have a fraction, negative 3/4, right, that can be written as negative 3/4, or it can be written as negative 3 on the top and 4 on the bottom, or it can be written as 3 over negative 4. All three of these versions here, with the negative sign floating in front of the fraction, or with the negative sign in the top, or with the negative sign in the bottom, they all represent the same thing, because a negative divided by a positive gives you negative, a positive divided by a negative gives you a negative. So either way, either place that you put the negative sign gives you exactly the same thing. So I have a choice. I can put the negative sign up here, or I can put the negative sign down here, or I can leave it out in front. But since I want to get rid of it, then I am going to bring it down to the bottom. So it kind of floats in front here, but I'm going to instead write it as s plus t. And on the bottom, I'll bring that negative 1 downstairs, t minus s. So then I have to multiply it, of course. If the negative 1 is downstairs, I will multiply and distribute it in like this. So on the top, I'm going to have the s plus t. And on the bottom, negative 1 times t is negative t. And negative 1 times negative s is positive s. But I don't like the order of that, so I'm going to flip that around. So what I'll have is s plus t. And on the bottom, I'll flip it around to s minus t. And let me check my notes. S plus t, s minus t. That's the correct answer. So again, you factor using difference of two squares. You realize that you're close, so you think you can simplify, but it doesn't quite work. So you factor out a negative 1, flip it around. Now they match. Cancel. Then you say, well, I think I'm done. And then you say, well, I don't like the negative out there, so I'm going to float it down there. But when I do that, I'll have to multiply in, flip things around to basically leave it in the simplest form with no negative sign in front. And this rational expression is identical to the one we started with. Just like fractions are identical even though they look different. So a lot of times on an exam or a test, you'll get the answer and you think you get it right, but you check your book or you'll check the solution and it's not quite right. And so part of the game with algebra is learning the rules, like with the negative sign, that I can put it upstairs or downstairs and do manipulations that are legal to do that can get it into whatever form you want to get it into. So that's why we're focusing so much on the rules, so that you can apply them. A couple more problems. What if we have x squared minus 5x plus 6 in the numerator, and then we have x squared minus 7x plus 12 in the denominator? So rational expression, polynomial divided by a polynomial. So we've learned how to factor polynomials. So we have to factor the top and bottom. So you should be good at factoring by now. And if you aren't, you really need to go back and practice that in my lessons on that. So the way we do it is we say we have an x squared term. So it's got to be an x times an x. And then we have a 6. Now we have choices. We can say 1 times 6 is 6, or we can say 2 times 3 is 6. So I'm going to say 2 times 3 is 6. And then you try to figure out what the signs are. Now the only way that it works is negative times negative. Now I'm kind of doing it a little rapidly because I have to teach you new concepts. But this whole concept of how do you factor these expressions is covered in excruciating detail on the lessons on factoring trinomial. So you really need to go back and go through all of those skills to get those skills where they need to be. Because if I spend 10 minutes teaching every single time I'm factoring, it's going to take forever. But you still want to check yourself. So what you do is you say x times x is x squared. Negative 2 times negative 3 is positive 6. And in the interior terms, I have negative 2x. These are going to give me negative 3x when I multiply them. You add those, you get the negative 5x. So that's correct. In the denominator, again, you factor. You have an x squared, so the leading terms are x. Now with 12, I have lots of choices. I have 1 times 12 over here. I could do 2 times 6. But when you work through all the possibilities, the only one that really works is 3 times 4. And for the signs, what really works is negative times negative. Check yourself. X times x is x squared. Negative 3 times negative 4, positive 12. This will give me negative 3x. This will give me negative 4x. You add those, you get the negative 7x. So the other options for numbers don't really work. This is the one that works. So you can see it right in front of you that you have a cancellation, but I still want to write it down separately here. X minus 2, x minus 3. And on the bottom, you have x minus 3, x minus 4. And so then you can see immediately that you can divide top and bottom by x minus 3. And so then the final answer will be on the top x minus 2, on the bottom x minus 4. I can put parentheses around the top and the bottom if I'd like, but I don't need it since they're in the numerator and denominator of a fraction. It kind of automatically means they're linked together as a term. So I can just leave it like that. So when you're simplifying these radical expressions, you will need to factor. So if you're not sure how to factor, please go back and practice that. In fact, we'll see that again in this very next problem. This is our last problem. 6y squared minus 5y plus 1, all divided by 1 minus y minus 6y squared. Now the first thing you're going to want to do is factor top and bottom, but the problem is the bottom is written kind of backwards. Usually you want your polynomials to be decreasing powers of y, like this one. Y squared, y to the first, and then no y at all. This one's written in reverse order. You can factor it when it's written in that form, but oftentimes it just trips you up. So take a minute in the beginning to turn things around and write it in the proper order. So the very next step, we'll just recopy the numerator, 6y squared minus 5y plus 1. And the denominator, we're just going to flip it around. This will be the first term, but it's negative 6y squared. This will be the middle term, negative y. And this will be the last term, positive. Positive's in front, positive 1. Now again, I can factor it with a negative here, but it makes it a little cumbersome. So instead of factoring it the way it sits here, I'm going to rewrite the numerator one more time. You know, you guys, when you do your problems, can do it any way you want. You can factor it like this. Sure, you could. But if it's me, what I'm going to do is I'm going to factor out a negative 1 here because I don't like having a negative for my leading term. So inside of here, I know it's going to then change the sign of everything. I'll have 6y squared plus y minus 1. Verify. This times this is negative 6y squared. This times this, negative y. This times negative times 1 times negative 1 gives you positive 1. So then what I have is a situation where I can then start to factor the top and bottom. In fact, I'll go ahead and switch colors to start the factoring process. On the top, I'm going to open two sets of parentheses here. Now again, there are choices. The leading term is 6y squared. I could do y times 6y, or I could do 2y times 3y, or I could flip it 3y times 2y. Those are all ways to get 6y squared. But the only way that's really going to work is if I do, or the way I did anyways, 2y and 3y. Now at the end you have a 1. The only way you can make a 1 is 1 times 1, so that stays in place. And then you have to choose your signs, and I am trying to make a positive here at the end. So the only way it works is if I have a positive numbers here in both places or negative in both places. But I'm trying to get a negative in the middle, so the only way it really works is if I have both negatives. So double check yourself. 2y times 3y is 6y squared. Negative 1 times negative 1, positive 1. Then the inside terms give you negative 3y. The outside terms give you negative 2y. You add those together, that gives you the negative 5y. So that's correct. If you go down the rabbit hole with other choices like 6y times y, then it's just not going to work. And when we learned the factoring in the factoring lessons, we went through all of those exercises, trying all the combinations as we went. Now on the bottom, we still have the negative 1, but we open up parentheses to factor this. Same thing, we have choices. What do we choose? Well, we're going to do the same thing. 2y, 3y. Here we have -1. The only way you can get a 1 of any kind is 1 times 1. So we'll put a 1 here and here. But in this case, it's different. We're trying to get a negative for the end here. So the signs cannot be the same. They have to be either plus minus or they have to be minus plus in order to multiply properly. So the way that it works out is plus minus. And the way that you check yourself is you say 2y times 3y, 6y squared. 1 times -1, -1. Inside terms give me 3. Outside 3y. Outside terms give me -2y. Add them together, I get a positive y, which is correct. So then you can see right away you have a cancellation. So let's go ahead and rewrite everything. We have a 2y minus 1, 3y minus 1. On the bottom, we have a -1, and then we have 2y plus 1, 3y minus 1. The reason I did all that is because we can just cancel this with this, right? And so what you would write down as your answer is you have a 2y minus 1 on the top, 2y minus 1 over, we have -1 times this. Now, if it were me and I saw a student give me this, I would probably just be done with it and just let them turn it in like this, and I'd be okay with this. But generally, you don't want these negatives sitting out, like I said, like out in front there. They just don't look so nice, so you want to get rid of it. Now, the negative can stay down here, or it can float in front of the fraction, which we don't like either, or it can float upstairs to be multiplied by whatever's in the top. So you just have to make a decision as to which way you're going to do it. So what we're going to do is we're going to just move this guy to the top and make it -1 times 2y minus 1, and on the bottom we'll just leave it as 2y plus 1. When we multiply this in, we'll get -2y plus 1 over 2y plus 1. And we don't like the way that's written. You can leave it like that, so I'm going to write it as 1 minus 2y. And to make it match with this, I'll flip that around too and make it 1 plus 2y. There's many ways you can write the final answer in algebra. You don't have to flip these things around, but it just looks nice and symmetric. 1 minus 2y, 1 plus 2y, which is the final answer. You know, you could leave it like this, but in general, again, you don't want these negative signs, so, you know, you can do it different ways. You could have multiplied it down here and then flipped the order. I ended up moving it upstairs because I liked the way it looked better. When you get down to the end, especially when you have negative signs floating around, there are lots of different ways to write exactly the same answer. But those are kind of down in the details. Those are down in the weeds. That's what I call down in the weeds, where it doesn't really matter so much. What I'm really trying to impress upon you is that rational expressions are very important, because real functions in real life, when we start graphing these things and talking about what they represent, we use them a lot. So we need to know how to simplify them, just like we have to learn how to simplify fractions. So the first thing you do is you factor top and bottom, then you cancel terms, and I've tried to do enough examples to show you how to handle it in practical situations. So practice these yourself, and then follow me on to the next lesson where we will get more practice with simplifying these rational expressions.